So in this video, we are going to go through U-Substitution. I'm going to take you through the basics of U-Substitution, show you the rules that I came up to remember how to use U-Substitution, take you through quite a few examples, and then give you some guidelines of how and when you should be using U-Substitution. So what is U-Substitution? U-Substitution basically reverses the chain rule for derivatives. So if you don't understand this, I basically say that it turns the integral into a familiar one we can solve with the different integral rules that I've shown you in my previous video, and I'll leave the link to that video up here. So please take a look if you did not have a look at that video with the different rules, because we will be using or implementing those types of rules in solving some of these integral problems in this video. So let's get straight into it, right? Like I said, let's look at the different steps. So I have broken down the way in which you use U-Substitution into 6 different steps. So the first step is you need to find what you want to make U. So basically what we're saying is in an example of an integral, we can say let U equal to 2x squared plus 1. So basically the first part of the substitution, find out or determine what you want to make U equal to. Once you've done that, the second step is you need to find du. Okay, very important, you need to find du. So if we use the same example, du is equal to 4x dx. Okay, so just ensure you have the dx, you have du. So you're finding the derivative of u. Your third step is a very important step that sometimes gets left, that you leave out, or you may leave out while working with U-Substitution, is try to find what dx is. This will make it quite easy to take this information and place it back into the original integral. So dx in this case is equal to du over 4x. So very important, find what dx is. Then your fourth step is to go back. So number 4, go back and substitute, right? So go back and substitute in the original. So let's say for an example, we had the integral of x to x squared plus 1 dx. And if we were to substitute what we found here in step 2 and step 3, we would now say that this is equal to the integral of x. This we made u, so that's a u du over 4x. Okay, so that's our dx. Quite simple. We can see that that cancels out. But I'll take you through this in a better example. The next step is to now evaluate. So evaluate the new integral with respect to u, and you need to ensure that you can take it through until the end and solve for this integral. And the last step is you just need to replace what you substituted. So replace u with what you made u. So in this case, we made u 2x squared plus 1. So just to recap the rules, right? So I broke it down to 6 major rules that you can remember. First step is to find out what you want to make u. So very important, what you want to make u. Find du. Then you need to find what is dx. Then go back to your integral and substitute for u. Step or rule 5 is to evaluate the new integral with respect to u, and then replace u. Once you've done evaluating, replace u with what you made u equal to. From this, the hardest step is actually step 1, because you need to figure out what you need to make u. This is the hardest step because if you choose the incorrect variable or that you want to make you would have an issue when you're trying to get to this lower steps, especially when you're trying to evaluate. However, don't worry, I will show you different ways in which you will be able to go ahead and try to determine what you should be upfront. So let's start and go ahead and look at some examples. Okay, so let's get into the first example. Let's say we want to find the integral of 2x minus 3 all cubed dx. And now let's say we want to use U-substitution to resolve this. So what is the first step, right? We need to figure out what we want to make U. So let's say we choose that we want to make U 2x minus 3. So let U equal to 2x minus 3. Step 1 complete. Let's move on to step 2. We need to find out what we want to make du. So du now is 2 dx. Okay, don't forget the dx. And then the last step is we need to find what is dx. So dx then is equal to du all over 2. Now let's substitute all of this information back into this equation or integral. So we're now going to have that we need to find the integral of, let's rewrite the integral first. So it's integral of 2x minus 3 cubed dx. So if we substitute back, we'll now have to find the integral of, we made this u, so that is u cubed. Our dx is now du over 2, and this is what we need to evaluate. Now if we evaluate this, we know that this is actually 1 over 2, so we can bring 1 over 2 to the front, and now we need to integrate u du. And if you can see here, this is now in a familiar format, and we can now use the power rule. So we'll now have half of u 3 plus 1 over 3 plus 1 plus c. That is now equal to 1 over 2 u to the 4 all over 4 plus c. And we can simplify this to say that this is now equal to 1 over 8 u to the 4 plus c. So we are now done with step 5, but however we are not done with solving this integral using u substitution. We need to replace u. So we now have this as 1 over 8. We made u 2x minus 3, so u is 2x minus 3 raised to the 4 plus c. Okay, quite simple for using u substitution. Just remember the 6 steps that I have discussed, and this will help you in using u substitution to evaluate and solve integrals. Let's look at another example. Let's look at an example where we want to find the integral of 2x into x squared plus 5 whole cubed dx. First step, we need to find what we are going to make u and du. So let's say we want to make u 2x. So if we make u equal to 2x, we can see that if we evaluate this with du, we'll have 2 dx. However, we will still have x squared plus 3 to deal with. So this is the first guidance I'm going to give you, is we need to try to get this to a point where we can convert all of the x variables to u, or we need to ensure that we can change the x variables to the point where it can be cancelled, or we solve x for in terms of u. Okay, so there is a lot that I just said. However, keep watching the video. I'll take you through different examples that would show you exactly what I just said. So in this case, we know we can't use 2x as our u because we will still have x squared plus 3 all cubed to deal with. Okay, so we know we also need to use U-substitution here if the question does not tell you that, because in this case, if we were to look at x squared plus 5 all cubed, it'll be a lot of work for us to go and solve this and break this out and factor it out, which will waste a lot of time in your exam, in your test. So let's, just by looking at this, we can see that we need to use U-substitution. So now I'm going to make u equal to x squared plus 5. So let's see what happens when we do that. So let u equal to x squared plus 5. Then we know that du is equal to 2x plus 0, derivative of a constant is 0, dx. So don't forget, always solve for dx as well. So dx is equal to du over 2. So now we have x squared plus 5 in terms of u. Let's substitute back and see what we get. So we now have the integral of 2x into u cubed du over 2. 2x, sorry. And we can immediately see that 2x here and the 2x there can cancel off, meaning we are now in the form what we want, where everything is in terms of u. So we basically now have need to find the integral of u cubed du. And this is once again in the familiar format. This is where we use the power rule once again. And this is now basically equal to u3 plus 1 over 3 plus 1 plus c. And that is now equal to u to the 4 over 4 plus c. Final step, don't forget, always ensure that we substitute back. So we know we made u x squared plus 5. So this is x squared plus 5 raised to the 4 all over 4 plus c. Quite simple, right? Quite simple, quite a good example where we looked at what we could make u. So first rule of thumb or first guidance, try to ensure that whatever you make u will allow you to get rid of all the x's by either cancelling out when you do make u, as we did here, where the 2x and the 2x to cancel out and we get everything in the term of u. So just try to get to the point where we can make everything in terms of u. Okay, let's look at an example where we have an exponent. So let's say we want to find the integral of x cubed ex to the 4 dx. So what do you think we need to make u here, right? So let's say we want to make u equal to x cubed. So our du is going to be equal to 3x squared dx, and our dx is then equal to du over 3x squared. Now if we look at this, right, and if we evaluate this just by looking at it, we can see that we will not be able to cancel out x ex to the 4, meaning we will still have a term with x in it even when we get to the step of evaluating this integral. So we can see if we make u equal to x cubed, this is incorrect and we won't get to the answer we are looking for. So let's go ahead then and make u, let's get rid of this. So we now want to make u equal to, what do you think it is? We're going to make it equal to x to the 4. So if we do this, we can find that du is now equal to 4x cubed dx, and dx is equal to du all over 4x cubed. Okay, so now we can see directly at this point, once we found dx, we can see that the x cubed from here can cancel out with the x cubed from there. So we would then have everything in terms of u. So let's substitute back in. Let's substitute in terms of u and see what we get. So we now have the integral of x cubed e to the u, since u is x to the 4, and we'll have du all over 4x cubed. And like I said, the x cubed here and the x cubed there can cancel out. So we now have this as 1 over 4, so the 4 pulling out the 1 over 4 from here into the integral of e to the u du. Now at this point we know that using our rules that I've shown you, that this is the same as the integral of ex dx, and the rule for exponentials is that this is basically equal to e to the x plus c. Okay, so this is now in the familiar format. This is the exponential rule. So evaluating and resolving this, we would now get this equal to 1 over 4 e to the u plus c, and if we substitute back, this is now equal to 1 over 4 e x to the 4 plus c. Okay, quite simple, right? U-substitution helping us to identify that we need to use the exponential rule. Let's look at another example. Let's look at an example of, let's change the color, let's use blue. So we want to find the integral of 6x, the square root of 20 minus 3x squared dx. So what is the first rule, right? We need to find what we want to make u. Now in this case, another guidance I can give you is, let's make u whatever's under the square root, or the one that has a lot of components to it, so which is the information under the square root. So let's make u equal to 20 minus 3x squared. Okay, so using the guidance of making u the one that has the most information in it, which is the square root of 20 minus 3x squared. So our du is then equal to 0 minus 6x dx. So our dx is then equal to du all over minus 6x. Okay, and at this point we can already see that the 6x from here and the 6x from there will be able to cancel out. So substituting in terms of u, we'll have the integral of 6x, the square root of u du all over minus 6x, and like we said, the 6x and that 6x will cancel out. So that's basically equal to the minus the integral of the square root of u du. So what do we do at this step, right? So like I discussed in the integral video, we can rewrite this as minus the integral of u raised to the half du. And now this is familiar, this is the power rule. So this is now equal to minus u a half plus 1 all over a half plus 1 plus c, don't forget the c. And that's now equal to minus u 3 to the 2 all over 3 to the 2 plus c. And this can be rewritten as 2 by 3 minus 2 by 3 u 3 by 2 plus c. We're not done as yet. Ensure that we bring back what we substituted for u, so that's equal to minus 2 by 3 into 20 minus 3x squared 3 by 2 plus c. You can either leave it in this format or you can simplify further. We know that this is the same thing as writing minus 2 by 3, the square root of 20 minus 3x squared, all cubed plus c. Okay, so quite a good example. Another tip or hint, you see the square root that has quite a lot of information in it, so more like a polynomial. That should then be your u. Let's look at another one, right? And this is a good one to actually know what to do to make u. So let's look at the integral of x squared all over 4 plus x, let's rewrite that, plus x cubed all squared dx. So in this case, what do you think we should make? U. So in this case, the hint or the guide I'm going to give you here is, let's make the information that has the higher exponent the value of u. So in this case, we can see that the x cubed here has a higher exponent than the x squared. So let's make u now equal to 4. So u is equal to 4 plus x cubed. So our du now is equal to 0 plus 3x squared dx, and solving for dx, that's equal to du over 3x squared. Okay, so let's substitute back, right? So seeing it from here, you can see that the x squared and the x squared can cancel off. So we know we are on the right track. So using the guidance of making the higher exponent equal to u is helping here. So if we substitute in terms of u, so we have x squared over u squared, x squared over u squared du all over 3x squared. We can see the x squared and the x squared will cancel out, so we now have the integral of 1 over u squared du over 3, and this can be rewritten as 1 by 3. The integral, we know u1 over u squared can be rewritten as u to the minus 2 du. And once again, this is something recognizable. This is the power rule. So using the power rule here, we can rewrite this as 1 by 3 u minus 2 plus 1 all over minus 2 plus 1 plus c, which is now equal to 1 by 3 u to the minus 1 over minus 1 plus c, which is equal to minus 1 by 3 1 over u plus c. The minus 1 is the same thing as writing it is 1 over u. Don't forget the last step. We need to substitute back, so that's 1 by 3 1 over our u, which is 4 plus x cubed plus c. Don't forget the c. Okay, quite simple guidance here. Try to make u equal to the higher exponent. So the higher exponent was this, so let's use this as the higher as u. Okay, so let's move on. Let's do another example. Let's do the example of, let's get another color here. Let's use green. Let's find the integral of the square root of 6x plus 2 dx. So what do you think we will make u here? We can see we can only make u this, so u is equal to 6x plus 2. So du here is equal to 6 plus 0 dx. So dx is equal to du by 6. Okay, so let's substitute back and see what we get. So this will now be the integral of the square root of u du by 6. And we can pull out 1 by 6. So 1 by 6, the square root or the integral of the square root of u. So u can be rewritten as, we know, u 1 by 2 du, and this is now in a familiar rule, which is the power rule again. So this is now equal to 1 by 6 u a half plus 1 all over a half plus 1 plus c, and that's equal to 1 by 6 u 3 by 2 all over 3 by 2 plus c, and we can bring the 3 by 2 to the top, and that's basically 1 by 6 multiplied by 2 by 3 u 3 by 2 plus c, and we would now get this equal to 1 by 9 u 3 by 2 plus c, which is equal to 1 by 9. Let's substitute back for u. So we made u 6x plus 2 3 by 2 plus c. You can take this a step further and rewrite this as the square root of 6x plus 2 all cubed, but I won't do that here. But if you want to, you can, because you could get a bonus mark for that type of simplification. Okay, so let's go ahead and look at another example. Let's look at one slightly more complicated. Let's look at the integral of x, the square root of 2x plus 2 dx. Now we can immediately see if we make u equal to x, we will still have the 2x plus 2. So as we mentioned earlier, let's make what's under the square brackets or the square root u. So we can say u is equal to 2x plus 2, and du is then equal to 2 dx, and our dx is then equal to du all over 2. Now let's take a look at this, right? We can see with this right here, it's going to be impossible for us to cancel out the x that's here right in front. So as we've been saying so far, we need to get to the point where we make all the terms in terms of u and try to cancel any of the excessive x's out. So at this point, we can see that it is impossible to cancel out the x right in the front here. So this x here. So we go back to the rule. We need to get everything in terms of u. So for us to do that, we need to find what is x in terms of u. Okay, so to do that, we'll use this again, and we'll say u, we know that u here is equal to 2x plus 2. Then we can take the 2 across, so we'll have u minus 2 is equal to 2x. So x is then equal to u minus 2 all over 2. Okay, so we're at the point where we can now get x in terms of u. So the entire integral should now be in the form of u. So let's have a look and see if that is now true. So we'll now rewrite this as the integral of a half. So taking the 2 from here, it's basically a half, and we know x is u minus 2, and then we know we made u 2x plus 2, so we now have this as the square root of u du by 2. Okay, so this is now our equation or integral that we need to solve for. So solving for this, we would be able to multiply this by that, and we would now get 1 by 4. A half multiplied by a half is 1 by 4. The integral of u minus 2 that we have from here, we can rewrite u as u to the half du. So what do we do next? Next is the simple multiplication of u to the half, and we multiply that out into u minus 2. So that is now 1 by 4, the integral of u to the 1, so that's u to the 1, multiplied by u to the half minus 2 u to the half du. Okay, so doing this multiplication, we'll have 1 by 4 u 3 to the 2, which is this, minus 2 u to the half du. Okay, we get the du. So now we can see that we are now in the power rule. Familiar one, the power rule. So solving for this, we'll get this as 1 by 4 into u 3 by 2 plus 1 all over 3 by 2 plus 1 minus 2 u to the half plus 1 all over a half plus 1 plus c. Don't forget the c because we are now implementing the power rule. So taking this further and solving it, we'll now get this as 1 by 4 into u 5 by 2 multiplied by 2 by 5 minus 2 u 3 by 2 multiplied by 2 by 3 plus c. So we need to simplify this, so we can now take the 1 by 4 and multiply that out there and there. So we now get this as 1 by 10 u 5 by 2 minus 1 by 6 multiplied by 2 u 3 by 2 plus c. We know this and this can get multiplied out, so we'll now have 1 by 10 u 5 by 2 minus 1 by 3 u 3 by 2 plus c. And now we go to the last step where we need to substitute back, where we know that we made u 2x plus 2. So we now have 1 by 10 2x plus 2 5 by 2 minus 1 by 3 2x plus 2 3 by 2 plus c. Don't forget the c. Okay, so this was a better example, a more complex example that you might get. Ensure that you are able to get everything in terms of u. If you cannot cancel out the x's, then ensure that you can get the x in terms of u. Okay, so let's look at an example where we use a similar method to what we used in the previous example. So let's look at the integral of 3x, the square root of 6x minus 3 dx. We know, as I've been guiding you, we should make 6x minus 3u. So let's make u equal to 6x minus 3. Du is then equal to 6 minus 0 dx, and dx is now equal to du all over 6. Now at this point we can see that the 3x, or the x itself, won't be able to cancel out with the information of the u that we have here. So we now need to solve for x. So we have u is equal to 6x minus 3, u plus 3 is equal to 6x. So x is then equal to u plus 3 all divided by 6, which is the same thing as writing 1 by 6 into u plus 3. So let's substitute back and make everything in terms of u. So we'll now have the integral of 3 into 1 by 6 into u plus 3, the square root of u du all over 6. Now let's start to simplify. Let's multiply this out. So we now have the integral of 3 by 6 into u plus 3. We can rewrite the u as the square root of u as u to the half du by 6. Simplifying further, we'll get the integral of 1 by 2 u plus 3 u to the half du over 6. And now we can see we can get the 1 over 6 here, and we multiply that by the half. And that's now equal to, we can pull that out, and that's 1 by 12, and that's equal to 1 by 12, the integral of u plus 3 multiplied by u to the half du. Now, similarly to before, we need to multiply the u out into the u to the half out into this brackets of u plus 3. So this is now equal to the 1 by 12, the integral of u 3 by 2 plus 3u to the half du. Okay, and now we got it in a format we can recognize. We can use the power rule for both of these. Okay, so taking it and using it in the power rule, we'll have 1/12 into u 3 by 2 plus 1 all over 3 by 2 plus 1 plus 3u to the half plus 1 all over a half plus 1, and don't forget the c. Okay, so plus c. Simplifying this, we'll have this as 1 by 12 into 2 by 5 u 5 by 2, 3 over 2 plus 1 is 5 by 2, right? So plus 3u 3 by 2 multiplied by 2 by 3 plus c. We're not done as yet, so let's continue simplifying. So if we multiply the 1 by 12 out into here and here, and this multiplied by that, we'll now get the answer as 1 over 18 u 5 by 2 plus 1 over 6 u 3 by 2 plus c. And if we now go ahead and replace u, we made u equal to 6x minus 3. So we'll have this as 6x minus 3 raised to the 5 by 2 plus 1 over 6, 6x minus 3 raised to the 3 over 2 plus c. Don't forget the c. So once again, another example where although we solve for u, we also have to solve for x in terms of u to ensure that we can get rid of the x's, so we only have u. Let's move on to another example. Let's look at the integral of x plus 3 into x minus 2 to the 4th dx. So what do you think we need to make u in this case? we can see straight off, right? If we make u any of this, we will still end up having to solve for x, okay, in terms of u. So let's make u equal to x minus 2, okay? Now the reason I'm making u equal to x minus 2, another hint or another guide is, I think I did mention this earlier on, the higher exponent. Let's make u equal to the one that has the higher exponent to it. So u is equal to x minus 2, du is equal to dx. So the derivative of x is 1, derivative of 2 is 0. So we will now have dx equal to du, okay? And we also need to solve for x because the x won't cancel out in x minus 3. So we have u is equal to x minus 2. So x is then equal to u plus 2. Now, let's substitute back in terms of u. So we'll have the integral of u plus 2 plus 3 u raised to the 4th du. Okay, we have everything in u as u, but we first need to simplify because right now we can't really tell which rule we need to use. So we know this can be rewritten as u plus 5. So and we'll have u to the 4th du, and like before we need to multiply the u into the brackets right here. So we'll now have the integral of u to the 6 plus 5u to the 4 du, and now we can clearly see that we can use both the power rule here and the summation or difference rule. Okay, so we can split this into the integral of u to the 6 du plus the integral of 5u to the 4 du, and that's equal to, we're using the power rule now, so that's equal to u to the 6 plus 1 over 6 plus 1 plus 5. Multiplication rule, we pull out the constant, we pull out 5 u 4 plus 1 over 4 plus 1 plus c. Don't forget the c. Simplifying this further, you'll have u to the 7 over 7 plus 5 u to the 5 over 5 plus c, and that's simply u to the 7 over 7 plus the 5 and 5 here can cancel out, so it's just going to be u to the 5 plus c. Quite simple. We can now substitute back, so that's equal to 1 by 7 into, we made u equal to x minus 2, so it's x minus 2 to the 7 plus x minus 2 to the 5 plus c. Don't forget the c. A bit of an easier one in terms of u substitution and solving for x in terms of u, but at the same time we are able to identify multiple integral rules that we could use to get us to the final answer here. So let's take a few examples of using trig. So let's go ahead and take the example of, let's take the integral of 2x sine 3x squared dx. So what are we making u in this case, right? So let's continue with the rule. Let's use the one that has the higher exponent. So let's make u equal to 3x squared. So du is equal to 6x dx, and then dx is equal to du over 6x, and at this point we can see that the x's will cancel out and the 2 and 6's, and the 6 will also be able to divide each other. So substituting for u, we'll have the integral of 2x sine of u du all over 6x, and that will now be equal to the x and x will cancel out. The 2 can go into 6 3 times, so we'll have the integral of sine u du over 3, and this can be rewritten as 1 over 3 the integral of sine of u du. Now we go ahead and look at our integral rules, and we know that the integral of sine of x dx is equal to cos of x plus c. So solving for this, we would now have this is equal to 1 over 3 minus cos of u plus c, and that is now equal to 1 over 3 minus cos of 3x squared plus c for substituting back, and that is basically what we have. We can bring the minus to the front, so we'll have minus 1 by 3 cos of 3x squared plus c as the final answer if you wanted to bring the negative to the front. So quite simple again. For the trig, still using the guide of the highest exponent here as the one that we will make as u, and then solving for du and dx, and in this event we were able to cancel out all the x's and thus did not need to solve for x in terms of u. Okay, let's do another trig example. So we have the integral of 6x cos of 4x squared dx. So using the guide again, we can see that the 4x squared is the highest exponent, so let's make that be equal to u. So let's make u equal to 4x squared, du is equal to 8x dx, so dx then is equal to du all over 8x. Let's substitute back. So we now have the integral of 6x cos of u du over 8x, and once again we can see that the x and x can cancel out and the 6 and the 8 can divide each other. So we would now end up with the integral of 3 cos of u du over 8, okay? And that is now over 4, sorry, let's rewrite that as 4, and that is now equal to 3 by 4 into the integral of cos of u du, which is now equal to 3 by 4. We know that if we are to look at our trig rules, that cos of u is equal to sine of u, okay? So sine of u plus c. So go back, check on your trig rules, and if we were to simplify this, we would leave it as 3 over 4 sine of, we solve for u again, so that's 4x squared plus c. That is your final answer. So quite important, again, remember your trig rules for integrals. So let's take another example. Let's use the integral of 3 cos of 6x dx. What do you think we'll make u in this case, right? So remember, the aim is always to get rid of the x. So we can see here the 6x So we have a 6x here, so let's make that equal to u. So u is equal to 6x, du is equal to 6 dx, and so dx is then equal to 6. So let's substitute back. So we have the integral of 3 cos of u du by 6. This and this can cancel out, so we are now left with the integral of cos of u du over 2. 3 can go into 6 2 times. So this is now equal to 1 by 2, the integral of cos of u du. So we know the integral of cos is sine, so we'll have this as 1 by 2 sine of u plus c. Don't forget the c. Now we can easily substitute back, so we have 1 by 2 sine of 6x plus c, and that's your final answer. Okay, let's do one more, or the last one for trigs. So let's do an example for, let's use a yellow. Let's say we have the integral of sine cubed x cos x dx. Okay, so what do you think we would make u in this case? Okay, so although this has the higher exponent, we know that if we do use cos of x as u, the du would be sine of x, allowing us to cancel out one of the sine of x's. So we can take that approach first and see what happens. So u equals to cos of x, du is equal to sine of x. So in this case, we will only have one sine of x cancelling out with one sine of x, meaning we'll still have sine of x that we need to solve for. So let's go back to the rule. As I mentioned, we can see that sine has the higher exponent. So let's try to solve for that and make that u. So let's make u equal to sine of x. So our du is equal to cos of x dx. So our dx is equal to du over cos of x. And we can see from this that the cos of x's will cancel out, so we won't have any x's remaining. So this is now rewritten as the integral of u cubed cos of x du over cos of x, and the cos of x's will cancel out. So we now are in the power rule format that we can use. So this is now the integral of u cubed du, which is, if you use the power rule, u3 plus 1 over 3 plus 1 plus c, which is basically u to the 4th over 4 plus c, and that is now 1 by 4. Substituting back, we'll have it as sine to the 4 of x plus c. That's the final answer. So once again, following the guide or the hint of using the one with the highest power, and making that u has assisted us here. So that basically takes us to the end of U-Substitution. So before we end off the session, just a few guides. So ensure that the one with the highest exponents, with the highest exponent, is equal to u. So this is one guide that I can give you. Another guide is when dealing with the exponential rule. So an example, e to the 4 As you can see here, we're also going to follow that rule of making sure that the highest exponent is equal to u in both trig and the exponential rule. And then working with powers. So always ensure working with powers, same rule, the one with the highest power, let's make that equal to u. Okay. And then just to end off, ensure that your aim is to get the integral into a recognizable format where you can use either of the integral rules. Try to get rid of x as much as possible. If you are not able to get rid of x, try to solve for x in terms of u, as we did in the examples. And if you are still unable to get rid of x, then unfortunately it could be that U substitution is not the right solution or the right method to use in solving these integrals. So go back, have a look at my previous videos on integrals and the power rules, and then try to tackle these type of problems, because once you get it into a format where you can recognize which rule you can use, you'll be good to go.